There you go. We got to 02 after the hour, so I think we can start, and it is being recorded, so people can watch it later on if they missed it. So I'll say hello, everyone. Good morning, good evening, good afternoon, wherever you are in the world. My name is Noam Dror. I run solution engineering here at SecuPi, and I'm happy to moderate this session of the webinar called Cloud and Data Sovereignty, the Best of Both Worlds. I'm happy to be here with two experts in the industry, and I think we'll start with some introductions. So Kevin, why don't you introduce yourself?
So, hi, my name is Kevin Keller. I work at Snowflake as a senior security architect in the field CTO office. And I usually cover all kinds of topics around the data governance, but as well also security controls, networking, integration with different tools, and in a way that is secure.
That's great. And I'm sure you know a lot of different customers and different challenges they have. So I'm happy, right?
Yes, I cover around 200 customers in the EMEA region, and a lot of these customers are in the financial services sector and the healthcare sector, highly regulated customers, also in Switzerland, Germany, Benelux, Nordics. So yeah, I cover a lot of customers, a lot of use cases. So I think I have a lot of good things to share today.
Well, that's good. I'm sure everyone will be happy to hear your insights. And our second expert and panelist is Alon Rosenthal. Why don't you introduce yourself, Alon?
Sure. Thank you for joining. My name is Alon Rosenthal. I'm the founder and CEO of SecuPi. I've been doing data privacy, data security for Fortune 500s over the last 15 years. I invented dynamic masking about 12 years ago. My first company was acquired by Informatica. And 7 years ago, I left Informatica to found SecuPi with a vision in mind to consolidate the segregated data security platform market. And I'm sure many of you are familiar with access control tools, encryption tools, as well as monitoring tools. And one of the main reasons we founded SecuPi is to consolidate it all in a single platform that will be able to help organizations comply with the ever-growing regulations from their mainframe to the cloud, from Teradata to Snowflake. In SecuPi, we've been serving over 100 Global 2000 customers from Asia Pacific through the PDPA, PDPB. Many of the European notable brands use SecuPi. Few Swiss customers, banks, insurance, as well as in the US, addressing both the GDPR, the CIPRA regulation, but also emerging more and more is the sovereignty laws, and hence the reason to have this webinar. And I'm really pleased to have you all come and join us.
That's perfect. Sounds good. So maybe what we'll do is have a series of questions so you can address them and discuss between you guys. And then if you want to use later on the slides to illustrate anything that would help our audience to understand, we can do that. And at the end, we'll have some time for Q&A from the audience. So let's start with one of the high-level topics here, which is privacy. And really the question is, what kind of privacy requirements are needed today when you want to use data? So Snowflake is a great data platform. What kind of requirements for privacy are there? So Kevin, you want to start?
Yeah. So in general, especially when you're looking at a cloud solution, so I'm not only talking Snowflake, but generally by whatever cloud platform you're using to process your data, you want to look at basically three pillars. The one pillar is the security within the product. What can it do? Does it have good governance controls in place? And does the tools that the product has, can you then, with these functions, can you meet your requirements that you have in your industry in your field in your country, in all the regulations that you follow, can you implement something with these tools that is aligned with what your requirements are? And then the other part is the cloud service provider per se also needs to have, of course, on their end, how they process the data, a good standing. So of course they should have like a SOC 2 type 2 certificate, ISO 27K, share the latest penetration test with you, the ability maybe to dig deeper, to ask, okay, we have reviewed your SOC 2, we have seen the certificate and your pen test, but now we want to see, can we have a look at how exactly is your incident process, right? How can we dig a little bit deeper? Because the SOC 2 type 2 will give you a lot, but sometimes there will also be high-level points that they say, yes, we have security and incident process in place, but it doesn't tell you necessarily how it exactly works. So the next step is then to ask, please show us the security and incident process or other things from the cloud provider. And then lastly, what would be good is that if the cloud provider that you're working with, once you have reviewed the standard certificates and reports and ask for additional information, that you also have audit rights, that you say, I need to go a step further and say there's something specific I need to audit, and that is allowed, right? And that you can then also have a third party, that you can run your own penetration tests, all of that. And the last part is, of course, the legal part, that the data processing agreement and other things that are pertaining to the contract have things in the contract that state that the cloud vendor is taking responsibility for safe data processing, right? So that there's a legal commitment that the data that the cloud provider does not access, use, modify your data at any point in time.
Yeah.
And if there's authorized access, how the process is then implemented technically as well as legally, that you're clear on these three things.
True. Yes. I would take it from a different perspective. From a perspective of a complete life cycle management of the data, right? Eventually what you need to do is, and we usually been asked, what is GDPR? What is CIPRA, right? What is PDPA and LGPD and others? In a nutshell, they require you access on a need-to-know basis. If you have the access on a need-to-know basis enforced across your cloud platforms, but as well as on your on-prem, you are in a good shape for those privacy regulations. Now, what does it mean, access on a need-to-know basis? This needs both to take to consideration the consent and the data of the customers from the ingestion piece, ingestion through the likes of Kafka and Talent and NiFi from the source systems on-prem, the SQL Server, the Oracle, the mainframes. As data being lifted to the cloud, we need to ensure that data is being de-identified as much as possible. Again, to address this need, on a need-to-know basis of the private information of customers, employees, vendors, etc. But that's the first side of the things. And then we have the second piece, which is to ensure that data is being controlled when accessed. Controlled when accessed using different types of tools, Power BI, Tableau, Click, but also native cloud applications, homegrown and packaged, and by different type of personas. Sometimes we see a limited view of that, where customers are only focused on the analyst, the data scientist, but that's far from what needs to be done. You need to look at all types of personas, not only on the data scientist, but also to the cloud admins, right? Even the AWS cloud admins that also need to adhere to this access on a need-to-know basis. Legal, offshore, outsourced teams, the viewpoint and the structure that you need to put in place to address the privacy regulations, and extended from that also the solvency requirements on top of that, require then both to follow the life cycle of the data from the creation of the data, ensuring that the data as it is flowing from on-prem to the cloud is being identified according to the law, but also on the consuming side of accessing the data, as well as apply different controls like controlling data at rest, encryption, and we'll mention a lot of different encryption functions, type safe, form preserving encryption, the pros and cons of those, but also even deletion. And we need to take care from the creation to the deletion of the data, of course, hopefully with a single platform, right? And that's really the idea, where we can address those different requirements through the life cycle from the creation to the deletion of the data.
Makes sense.
Some really good key points here, right? Many cloud providers, I'm now talking from the perspective of Snowflake, but what I'm saying is generally applicable, right? There's many best-in-class security features there today, but all of the systems will eventually have an account admin or an administrator or super user or something like this. So how do you make sure that these super users do not access sensitive data? Maybe they are your super user is in a country that the super user can then access data theoretically in a database from another country, and they can give themselves access rights. Yes, you can audit a monitor, you should have that in place, and you can catch that, and you can remediate this, but it would be better if that wouldn't be possible in the first place, right? That's what you, so when you, now with a platform like SecuPi, you transparently encrypt highly sensitive data and decrypt it transparently only for the people with the right attributes at the right location, for example, in the right country. You're forcing them, enforcing it, that only then these people can see it, no matter if they're a super user or not, right? And yeah, sorry, let me stop there, right? So I think it's a really, really important point.
Yeah, and when you mentioned also around that, right? Take for example, and we have a large Swiss bank that uses not only Snowflake, but on top of that, the likes of the Nodo and Starburst. And the major question there was, how can we ensure that the administrator of the Nodo and Starburst would not be able to abuse the extensive accessibility of those tools, right? Who controls the administrator of those tools? And of course, for Swiss banks, for financial organizations, telcos and healthcare and regulated customers, this is a major challenge. Also to the fact that those data mesh tools, the Nodo, Starburst, the Trino, and others, they are also caching data themselves, right? So sometimes you need to extend the controls from the cloud data platform themselves and extend the controls to other environments up the stream, such as the caching that the Nodo, Starburst, and others are doing. And even applications are now doing some caching for accelerating the speed and the performance.
Yeah, very important point. So when you are discussing with cloud vendors, it's always important to ask what is cached where, right? Where are you caching my data? For example, if you're running a query, the result set of a query will be cached somewhere for some time. How is this protected? That is, and there's also, of course, caching of this cloud providers today, Snowflake as well. You know, we have sophisticated encryption already inside the platform. But of course, there's also and key rotation. There's a lot of good stuff already. But make sure you're familiar with the encryption that is provided by the cloud provider and where the limitations are, and where, you know, and then SecuPi, obviously what you just said, will fill any gap there, right? That may come up.
Yeah. So it sounds like you both talked about different challenges here, different users that needs to access the data and they need to know. What I heard is that encryption and different privacy enhancing techniques is key solution for this. Can you explain a little bit more about what's available in the market in terms of privacy enhancing techniques?
You mean in general? Yes. And this is usually, so how you should go through this is the first question to ask is how do I access the data? Usually over a network, right? So this is the first layer that you ask yourself, how do I secure the network? Usually, if you can use private link, AWS private, Azure private link, GCP private connect, use that, connect to your cloud provider, your clients through a VPN or direct connect express route, right? And then use maybe different firewalls or network policies inside the cloud solution to basically stop public internet access to your cloud solution. And once you have figured out a safe access pathway to the cloud solution, the next thing you need to figure out is authentication and user provisioning. So how do you want to provision users when they leave the company, when they join the company, when they change the company? There you should look for so SCIM is often used to provision users and groups to a cloud solution, and also change groups depending on in which, for example, you're using Okta or Azure. When they change, if you move them in different groups because they change jobs, make sure that this can be, automation is key in everything, right? For security is very important. So if you can automate this using SCIM, you should do that. And also make sure that you use a good authentication method, SSO, SAML, OAuth, wherever possible, OAuth and SAML, and have conditional access policies, multi-factor authentication.
Yeah.
And once you have figured out networking, you have figured out authentication and role provisioning and user provisioning, then you need to figure out data governance. What data do I have? Where is the data? In which tables and columns? Is there PII data? Is it sensitive? Is it highly sensitive? Why do I have that data? For how long do I need this data? When can I delete the data? And then we go into already things like GDPR. Is there somebody is asking to be deleted? Can I delete this data? How do I want to delete it? What does deletion mean for my legal department? Is this a crypto deletion? Can I just purge it? Many things to consider, but this is the next part, data governance. What needs to be masked from whom? Who can access what? And once you figure that out, you should always look into encryption and bring your own key and additional encryption. Also, this is a key topic for today, right? And then also other things that are important. Is a key thing that you always need to also think about is auditing. What can I audit? How deep can I audit? For monitoring, how can I connect to my SIM system? So yeah, I'll stop there. So these are the key things to consider in this regard. Sure.
And yeah, you mentioned the security, but in a sense, the security by design, right? Automation, and one of the things that we have developed over the years was those plugins that we can put on the ingestion tools, that where you specify the source tables and the column names. For example, you might specify your customer table in your Oracle database, and all ways to the data through an Informatica ingestion process, or Talent, or a Kafka producer, or it can be an IFI process, whatever. Once each one of those ETL tools would point and would pull data from this source Oracle customer table, we have built those integrations into each one of those tools that would automatically apply the same consistent encryption, filtering and masking on the data that is consumed from those source sensitive tables in your Oracle, DB2, SQL Server, Teradata, and others. And it helps a lot with ensuring that the sensitive data, the critical data, is really encrypted and masked consistently without any glitches that you found out that certain tables, certain data was not encrypted in Snowflake or in other cloud data platforms. So that's something that we invested a lot in to ensure that, automation helps you to ensure the governance of the data. Also, talking about, and you touched the need to encrypt the data and to allow the decryption on a need-to-know basis to address the sovereignty laws, especially in Europe and others, right? And we have invested a lot of effort into building those transparent gateways that can be distributed in different locations, completely segregated from the cloud account admins. So nobody can, from the cloud perspective, no unauthorized user can even access both the keys as well as the decrypted value. And simply by pointing your BI tools and your data application to this transparent gateway, the transparent gateway will apply the re-identification, the decryption on a need-to-know basis, based on the policies that you manage centrally. So having be able to completely segregate the decryption functionality, so the data is not returned decrypted to the cloud data platforms, but the data is consistently encrypted in the cloud data platform. So even the memory of Snowflake, BigQuery, or Redshift and other, even the memory of those cloud data platforms will never hold the clear text data.
Excellent.
Yes. Yes, please.
Data and memory. So basically, you are guaranteeing, you could say that is confidential compute, right? Because the data will be processed. So you're running a Snowflake query. The data is encrypted in the Snowflake memory. It is encrypted in the Snowflake result cache. And it will only be decrypted in your when it hits your transparent gateway that are in the customer's cloud or on-premise transparently, right? So the data is always encrypted all the way up to the point where the user is looking at it, right? Yeah.
Also, regarding encryption functions, right, and taking that to the level of the specific column, there are some common encryption that is provided, like tokenization, form preserving encryption, AES encryption, AED encryption. The limitation there is holding the same type of column, right? Because, for example, if you encrypt an integer, the form preserving encryption of an integer might be long, which might require you to change your schema or require you to do some hefty transformation all the time. And that's why for this privacy enhanced technology, we also enhance this functionality with, for example, type safe encryption, where we can take, for example, an integer, encrypt it into an integer, or take, for example, a date where the form preserving of the date can be the 38 of the 130066, right? It's the same form preserving encryption, but it's not the date type. And hence also extending the different out-of-the-box encryption functionality with type safe. And also blurring, for example, when you take blood type A or gender, right, and you just consistently encrypt it into two values, you might be vulnerable to statistical hacking because there are more female than male in any large population. And hence also being able to blur the data into multiple values is also something that needs to be taken into consideration to address those privacy concerns of large data sets. Yes.
Yeah, let's talk about also, so yeah, very nice. So that you have the screenshot here and you can see that, right? And this is how the data will then look like in your cloud solution. This happens to be, of course, a Snowflake screenshot, but for the user, when they query it, if it's the right user in the right location with the policy enforcement point, they will see the data in plain text. Hence, they will be able to do data transformation. They will be able to do data exploration, because for them, they don't need to worry about that the data is actually encrypted in the background, and you don't have to change the schema, is also what you said, right? So an integer stays an integer, a decimal stays a decimal, a string stays a string, right? A date stays a date. Dates are especially hard to encrypt for data type preservation encryption. So you don't need to change anything in your data, and you have the ability to enforce this encryption all the way, and your users won't forget to encrypt data, because the data will also be ingested, encrypted automatically through these endpoints. So yeah, I think this is really great, and this is also why I'm highlighting this is because when you hear this type of, when you hear encryption, that sometimes people just encrypt data, they just use plain AES encryption. What that means for your data, if you think it through, it means that an integer will become a string, right? And then you need another column next to the actual column that the integer might be a number like 55, but 55, when you encrypt it, AES encrypted, it will be mumbo jumbo long string. So you have to have another column in that, change that table, and then there will be, and if you do that, if the scales, it will become very complicated. So what you have here to keep the schema as it is, it also makes it hard for data science, data exploration, machine learning, all this statistical stuff. Sometimes you don't know, even when you encrypt, right? There are solutions out there, you encrypt it, and then you can decrypt it, but then you only if you always run the same report, right? You have the same Power BI or Tableau report, and it runs a couple of things in the background, sort procedures and whatnot, and then it will work. But then when somebody wants to explore data and say, hey, we want to explore and make new connections and explore it, then you will have a huge challenge with data exploration. But with this, since it's all transparent and the data types are preserved, you will not have these challenges at all, right? It will be all natural, working with the solution as it is, as it were natural, right?
So it sounds like you said it will, one, be format preserving, so it would look like the data that you want to see in that field. Two, it sounded like you said that it will go across multiple data stores, so it will be in Snowflake and in other databases the same way. And it sounds like it will keep referential integrity. So if there is a user here, I don't know, named Kevin, then Kevin would look the same, even though it will not say Kevin, Kevin would look the same across those data sources, right?
Yeah, that's definitely something that can be done, right? With this, that you can still do SQL joins on that you have some, so that you some columns that Alon mentioned, you want to encrypt them non-deterministically in order to prevent statistical attacks, right? But maybe some other columns that are sensitive-ish, but not that sensitive, that can be used as for SQL joins, like ID fields. We have an ID field here, for example, as well, or some other fields that are not as sensitive and can be used for SQL joins. You can encrypt them deterministically with this as well, right? And you can mix and match, and then you can join data on this encrypted values. And still, the key here to understand why that is valuable is that you can also, so other colleagues that don't have the enforcement point can still work with encrypted data and join on these sensitive columns, and then work with the data that comes out of the SQL join that is non-sensitive data, non-encrypted data, and run a report and still have analytical value, even though they're not decrypting. So that flexibility is also very important when you look into something like this.
Yeah. Also, another feature that we added was the ability to do partial encryption. For example, we've done it with the largest European telecommunication company. They wanted to encrypt the phone number, but keep the country code in clear. Right. So we can take, for example, just pieces of the social security number or a phone number and just encrypt partial values within the entire number, so you can search the country code, you can run analytics on the country code because it is kept in clear, similar to the last 3 digits or the 4 digits of the credit card, etc., right? So also partial encryption is also valuable to take into consideration. Yeah.
So that was good overview of the different encryption and the format preserving encryption and different privacy enhancing techniques, which is great. You can change the data so people will not see the actual data. How is it all connected to access control? So who gets access to the data? Can you expand a little bit about that?
Yes. So this is a really challenging question, right? In order to apply a true attribute-based access control, you need attributes. And you need to be able really to pull attributes from multiple sources, mash them together, and then push them down to the different enforcement points. Taking, for example, maybe a classification and tagging of data in Collibra or Alation. Taking into consideration, for example, your hierarchy within maybe SailPoint or Okta or even Workday or SAP HR. Right? You want to enrich the access control with attributes coming from different sources, both on the user as well as on the data. For example, we talked about right to be forgotten, consent-based analytics. This is another attribute that we need to take. Maybe we'll take it from OneTrust, or maybe we'll take it from a database that holds those consent authorization that we need to take into account when analyzing the model. So how do you do that at scale, right? And how do you do it to be future-proof? Because in the future, we'll need to have more attributes, more policies taking into consideration. The old approach of trying to copy those attributes and maintaining them in a table is of course very problematic. It requires a maintenance, it requires updates, it requires creating views to use those attributes all the time. And what happened with the new attribute that was added to this model? How can you ensure that the attributes are refreshed accordingly? So hence, we have built an entire processor, and this processor within the SecuPi platform is integrated with numerous types of user identities through SAML assertion, through SAML hooks, as well as with different data classifications, as well as data attributes from Collibra, Alation, Big ID, OneTrust, and others, to pull all of those attributes using API, REST API, web services, etc., into a centralized cache in the SecuPi platform. And then what we do is we push down the relevant elements that have policies related to them to the different enforcement points, to, for example, the Snowflake gateways, to, for example, an overlay that we'll be using on Informatica to encrypt certain elements based on the classifications of Collibra, or based on an application that we can put what we call an application overlay, for example, on a Java application, a native cloud application that would pull data. So with a centralized processor that maintains the updating of all of the attributes from all of the sources, taking this and pushing it down into the memory of each one of the enforcement points that SecuPi has. And we have 5 different types of enforcement points on application, on a gateway for Snowflake, as well as native capabilities. We take care of all of the attribute propagation, maintainability of those attributes, and then enforcing the policies on top of them. Because we do everything in memory, right, we are ensuring that the performance is always top-notch. So all of those attributes are being pushed down to the enforcement point to be executed at the optimal performance, because the filtering that those attributes are taking into consideration will be done in memory. And we can do it on a column, on the row, on the cell level, on the data set level, even on a database level. So that's a bit of a context about attributes. Kevin, anything from your side on that?
Yeah, it's very great that this attributes, right? To put it in context, right? It is basically putting context around a person, right? More than just a username and email. You also have all kinds of other attributes, maybe the location, or maybe attributes and about this person from other systems, as you said. Can be taken into account. Apart from Azure or Okta attributes, you can also take into account attributes from all kinds, from your HR systems and all, as you said there. Just in putting a nice picture around a person that goes far beyond just the normal, simple that the one application per se can provide, right? If you just use Snowflake, or if you just use PostgreSQL, they have only so many attributes that they can take into consideration, but you are adding so many more on top of that. and then you're pushing them into this policy enforcement point, which can be in the customer's cloud or on premise, in front of this solution, then can evaluate as the request as it comes in and make sure that only the data is decrypted on the fly when the context of the person and the access context fit the access, right? So just to summarize that, and I think this is really amazing. I think on the next slide you have prepared something wrong now.
Yes, it's an example of when you don't do it right? For example, when you use a data application that is open for thousands of users, you will use a connection pool, connection multiplexing to Snowflake, and hence the user attribute would not be propagated to Snowflake. The location, the device, the role, the citizenship, and other attributes cannot be propagated to Snowflake. And hence, in this example, what we are able to do is to put an enforcement point on the application itself that will take into consideration the user request, the data response, and the user response, pulling attributes from those sources, from the session itself, from the user connecting to the application, and applying the policies on the data application itself. And here we use the capabilities such as Java instrumentation, .NET CLR, profiler, that can do this privacy enhanced functionality on top of a native cloud application, a custom home-grown or a package application that organizations are using with zero code changes. And no code changes are required. We simply put a jar file on a Spring Boot application that is connecting to Snowflake or Postgres, and we'll be able to apply the relevant filtering, the relevant auditability required by GDPR, required by other regulations, and enforce that with utmost scale and efficiency. Again, with zero code changes. And you can see as you're progressing through the application layers, right, more and more context is getting lost, right? Because on a data source, right, you don't know the OS user, the application username, right? Other elements, other attributes that are available on the application are getting lost through the movement of the request through the application layers. And that's what we're trying to overcome by having those different type of enforcement points that will be installed and configured even on the data application themselves to provide this fine-grained access control on a need-to-know basis.
Yeah. You know, we talked about data catalogs before. I know a lot in data catalog, you talk about data lineage, what happened to the data since it started and how it progressed. This one sounds like user lineage, right? What's the journey of the user from the original one through how they got into the data at the end with the system account, right? It sounds like there's a journey there of a user. Okay.
Yeah, and it enables you, no matter what backend solution you use, be it Snowflake or other databases, you can use like 5 or 6 or 10 or maybe 1,000 at most, maybe connection in a connection pool, right? And then serve millions of users. So you could create a data application that you know, like a 360-degree marketing application that pulls data from various sources and make it available as a consumer application, maybe, and that's have it secure and scale it, right? And having using not millions to connect, having millions connections open to a database is madness. That will not scale. So with this, you can have just a couple of connections open, but you can multiplex and serve millions of customers on the front end while staying secure. So it's also something that enables building large-scale applications in a secure manner.
So talking about scale, Kevin, maybe you should tell us a little bit more about what's native in Snowflake in terms of privacy and security and how that can, you know, scale into a Snowflake type environment. Yeah,
so I was thinking still we have 20 minutes left. But we can always start opening up for questions. I will definitely touch on what Snowflake can do. So or maybe let me quickly touch on it. And then we open it up for questions. So just to be very clear that Snowflake is, of course, the best in class cloud solution with a giant list of security controls. You can classify data, you can tag data, and then apply all kinds of different policies, external tokenization or access policies. There's a lot of stuff that you can do in Snowflake that already protects your data perfectly out of the box, and we're meeting even the most stringent customer, with the most stringent regulations, etc. But sometimes, so this is all out of the box, and it's also really great when you consider that you don't want to always load data encrypted into Snowflake. Maybe there's also some data you want to not have encrypted, also for different reasons. So, and then you can apply Snowflake native governance here, which is extensive, right? And what SecuPi brings in here is that you go the extra mile, right, to have this on-premise type of control over your data, where you only decrypt on-premise. That is something as a cloud provider, Snowflake can just naturally not offer, right? Because we are a cloud provider, we take advantage of the cloud, and not we are not something that we don't want to install things in your cloud or on premise, because we have other priorities. But sometimes that is needed and extremely useful, right? With the quite often actually for regulated customers, that's what we touched on today with all the enforcement against super users, Snowflake super users or other super users, or enforcement points for local regulations where you have to enforce that somebody can only decrypt data in a specific office even, right? Going down to that level, that cannot possibly fall on the cloud provider. And this is really where the best of both worlds come together, where you say, yeah, so I talked longer than I wanted to. So yeah, maybe we can open it up for questions.
Yes, let's do that. So everyone, you see there is a Q&A button at the bottom of your screen. Please click that, write your questions. We'll be happy to answer it. And let's start with the first question. So the first question I see here is about performance. So how do we need to look at performance in terms of a security and a privacy type of a solution? What are the measurements there?
Sure. So, right, the performance is always very important, because, of course, Snowflake is a super effective data source. And the way that we do that is by providing a distributed set of enforcement points, right? We talked about the gateways that are Kubernetes cluster with autoscale. We talked about the attribute propagation in memory to those enforcement points that allow us to do that in a millisecond speed, and hence the security is really done by design to support the high speed and velocity of Snowflake. And the attestation for that, of course, is our global customers, and we address the performance of a telco grade customers. In some cases, even SecuPi has been deployed on CRM applications to provide the likes of access control and deletion requirements to telco grade applications with thousands of requests per second.
Okay. Next question I have here is, does a given string end up in the same encrypted form at all occurrences? For example, if two tables having the same email ID are joined on one column, would the encrypted string for each email ID will be the same in both tables?
Yes, of course. The consistency is very important. So we allow the consistency. By the way, even if the data has been ingested using different ways, right? You might have Informatica and Golden Gate and Talent, whatever, right? They will be ingesting different data from different data sources. We will ensure that the data is encrypted in a consistent way. Keys, by the way, can be either on-prem HSMs or in one of the cloud KMSs in order to provide a consistent view of the data wherever it flows across the cloud.
Yeah, on-premise keys, right? That's also a key requirement, using Thales, using a Thales HSM, or maybe using sorry, I forgot the name now. HashiCorp Vault, for example, on premise. I understand that maybe you can help me with this. You can encrypt data deterministically or non-deterministically, and you can choose what you want. For example, in the question was the sample of the email, right? An email is actually a great, I think, example of what you could encrypt deterministically, meaning that the email, when you encrypt it, will always come out with the same encrypted string. And so that means consistently you can then join on the encrypted string for people that cannot decrypt the data, but can still join on the encrypted email. Because why is, for example, an email a good example? Because a statistical attack on an email address is a very, I don't know, it's close to impossible. I mean, email addresses, for example, if you have email addresses from the same company, half of them will already have always the same domain anyway. And there's not many statistics you can use. You can maybe try to figure out the email addresses from employee names, from Googling. But I mean, you know, there's not too much you can do. And even if you somehow reveal an email address, it's not something super sensitive, right? So, and it's a great identifier to use. So on the other hand, what Alon mentioned, for example, if you're in healthcare and the blood type needs to be kept secret, you want to make sure that this is encrypted non-deterministically, meaning it always comes out. It's still data type preserved, the format preserved, but the encrypted value will always look different every time when you encrypt the original. So in order, because their statistical attacks would be possible, and figuring out a blood type is much more sensitive for HIPAA, for example, and all that, than is to try to figure out an email address, right?
Yeah. Okay. The next question is about deployment. How do you deploy this? What are the major concerns?
Sure. So from a deployment perspective, we are basically providing a Docker for the management server, and it can be deployed either on premise or in any one of the clouds using ACS, ECS, AKS, GKS. So the deployment is quite straightforward. By the way, we have no access to the SecuPi from the SecuPi side. Namely, you can even install SecuPi in a dark room. Okay, we are serving, for example, the U.S. Department of Defense, and they are deploying SecuPi in a dark room without us at all, right? And this is, of course, very important because we are not a data processor. We have no access to your data. We have you just take the software and install it yourself, basically.
Okay, that's good. So let's see. I think we are kind of out of time. So I think maybe it's a good time to stop here. One, I'd like to thank you, Kevin, and thank you, Alon, for great insights and a good webinar. And thank you, audience. Hope to see you in one of our future webinars here.
And in Snowflake Summit, guys.
And
we'll be there.
Snowflake Summit, of course.
Yeah, that would be
Looking forward
cool.
to see you there.
See you in Vegas.
In Vegas.
Sounds good. Thanks a lot, everyone. Take care.
Take care.
Bye-bye.